Okay, video 2 in the homework week 7 series for grade 11 math. Okay, so we're still on B1, but now we're going to do exponent laws. Probably all of them you already know. So let's just go through all of these. Okay, this is just a quick summary of all of the exponent laws we should know, and if you don't, then just get to know them now. So we've got a multiplication law. So if we multiply two things that have the same base, we can add their exponents. So if you want a number example, say you had 2 to the power of 3 times 2 to the power of 4, that would equal 2 to the power of 7. I'm just using numbers, or sorry, I'm just using letters like variables so that we can just put the general rule down. Okay, division. So let's say we have two things divided by each other. They have the same base and they both have an exponent. Turns out the division rule is just to subtract our exponents. So here you go, number example if you need it. Say we have 5 to the power of 4 divided by 5 to the power of 2. We just subtract their exponents and it would equal 5 to the power of 2. Okay, power of a power. So if you have two exponents side by side, you just multiply them. So this would become a to the power of m times n. And an example with numbers, let's say we had 2 to the power of 3 to the power of 4. If we wanted to simplify that, we would just write that as 2 to the power of 12. So we just multiplied their exponents. Okay, the 0 exponent is anything to the power of 0 is always 1. And finally, the negative exponent. This one's the trickiest. We never really want to leave things with a negative exponent. So it turns out if you have a negative exponent, you can make it 1 over a to the power of m. And you could write it like this. Or I guess you could also write it like this because 1 to the power of m is going to be 1. Okay, so exponent laws. So let's simplify some stuff using them. So here are a bunch of expressions, and we're just going to simplify them as much as we can. So if we've got a to the power of 4 times y to the power of 3, and everything is to the power of 2, we're going to use our power of a power law and multiply those exponents. So this would become x to the power of 8, y to the power of 6. And we can't do anything with those two things because they have different bases. Okay, let's do the same thing we just did for this, but I threw in this coefficient here just to let you know that it's also included in this stuff. So currently this is actually like 2 to the power of 1, so it'll become 2 to the power of 3, x to the power of 6, y to the power of 12. And we could take that one step more because we know 2 to the power of 3 is actually 8, so we might as well solve that. But then there's nothing else we can do with the x and y. Okay, let's try this fraction. So we're just simplifying everything we can. So I'm going to start with these numbers. So 2 over 8, I know I can simplify to 1 over 4. X cubed divided by x, I know will become x squared if I subtract their exponents, 3 minus 1. And then the y's are weird, y minus y7. Well, that would end up being y to the negative 3. But I don't ever want to leave a negative in as my final answer. So I'm actually going to take that y and put it on the bottom of my fraction. So it'll be positive, which actually makes sense. Because if you look at this y situation, y to the power of 4 means y times y times y times y over 7 on the bottom. 5, 6, 7. So if you think about like canceling y's, if I canceled out y's, I would actually end up with 3 y's in the denominator of my fraction. So that's why we would leave them down there. Okay. You can also just evaluate exponents if you need to. So using a calculator or your brain, 2 to the 4 would just be 2 times 2 times 2 times 2, which would equal 16. If I had to evaluate this, I would first use laws, so 2 to the power of 2, and then I would evaluate it 4. Same with this one. I would use my exponent laws, power of power, so multiply the exponents, which would give me 3 squared, because 4 times a half is 2, and then 3 squared is 9. And that's pretty much all there is to exponent laws. They can get kind of crazy. We didn't do too many crazy ones, but more on that in the next video.